Okay, so now we're going to explain how our program in the Arduino is going to convert that voltage into temperature, or how we're going to help it to do so. The first one thing I didn't point out in the last video, so I'd like to point out now, if the resistance of the thermistor gets low enough that it's actually zero, it'll never get to fully zero, but the lowest it'll ever be will be zero. When that resistance is zero, effectively, that means that the voltage between here and here is zero. So if that's 0 volts, that's also 0 volts. So the minimum that your output voltage can ever be, V out minimum, will be 0 volts. On the other extreme, if the resistance of the thermistor is huge, effectively, if it's huge, if it's infinite, that means you've effectively no connection between here and here. It's so high a resistance that the current just won't flow, okay? Or pretty much no current will flow. And if pretty much no current will flow, that means you get pretty much no current through here, which means you get very little voltage between here and here, which means that your output will be the same as your 5 volts because there's very little between them, very little difference in voltage across this resistor. So V out max is 5 volts. Now that's important for the next bit, okay? Right. So now we're going to look at our program. Now very basic, just really more in relation to the thermistor. So we now know that we are going to get a range of voltages anywhere between 0 volts and 5 volts. And those voltages will correspond to the temperature of the thermistor, okay? And remember, when the temperature of the thermistor is high, that means the resistance is low and it means the output voltage is low. So a lower voltage means a higher temperature and a higher voltage means a lower temperature. Okay, so what we want to do now, remember what was happening. Our output, this output from the thermistor circuitry was going into this A0 pin on the Arduino. Now that is known as an analog input. And the way the Arduino works is, it represents the analog input as a digital number. So if the analog input can go from 0 to 5 volts, the way the Arduino works is it uses 10 bits to represent a number, okay? So it will represent 0 with 10 zeros. That's 0 on the Arduino. And the 5 volts is going to be represented by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? Now, counting in binary, I'm going to do a small example going from 1 to 8, okay? So if you have 0, 0, 0, 0, that's represented by 0. 0, 0, 0, 1 means 1. 0, 0, 1, 0 means 2. 0, 0, 1, 1 means 3. 0, 1, 0, 0 means 4. 0, 1, 0, 1 means 5. 0, 1, 1, 0 means 6. And 0, 1, 1, 1 means 7. And then 1, 0, 0, 0 means 8. And it continues on. 1, 0, 0, 1 is 9, and so on. Okay, that's how digital counting works. It's called binary. So the Arduino now has, just let me tell you, that when you count from here to here, you're actually counting from 0 to 1023. So there are 1023 different numbers between here and here. And the Arduino will use those, a particular value, depending on the voltage, it will use that number to represent the voltage. So 5 volts is represented by all ones, 0 volts is represented by all zeros, and this number is known as 1023. If you were to count it, this number is 0. So what we have to do in our program is, because the Arduino is going to, when it reads this voltage, it's going to immediately turn the voltage into a number related to the voltage. Okay, so for example, if it was reading 2.5 volts, the Arduino would read the number halfway between 0 and 1023. So we'll say it would read the number 512. Okay, and the number 512, ooh, I should have thought about that. The number 512 is, let me see, that's 8, 16, 32, 64, 128. So here, 512. So that would be the number 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, I think, okay? So the Arduino would then read, if for 2.5 volts, it's going to read the number 512 because that's halfway between these two. So we need to tell our program, we want to get back out the actual voltage. Okay, so we need to tell the Arduino, take that number that you're after turning it into, and we want you to divide that number by 1023 to give us 1 unit. Okay, so whatever the Arduino reads on A0, it's going to be a number between 0 and 1023. We know that if it was 1023, we know that that's supposed to represent 5 volts. So basically what we say is, it's the number on the Arduino divided by 1023 and multiplied by 5. In other words, whatever number on the Arduino as a fraction of 1023, then our voltage is that fraction of 5. Okay, so let's take for the example there, if you had, what did we say it was, 512. 512 divided by 1023 multiplied by 5 should give you something very close to 2.5 volts, okay? Because that is halfway through 1023. So what we need to do in the program is we need to tell the program, first of all, you have to tell it, the way a computer works, you have to say pretty much, you're telling it to go to the input and tell me what's on that input and put it into a box called, I think in this case we call it sensor value. Right? The computer always stores things in little boxes, okay? So what you're saying to the computer is, read A0 and put whatever is in it, we'll use the example of 512, into this box called sensor value. What you then have to do is, you have to perform a calculation now, or tell the Arduino to perform a calculation. You're saying to the Arduino, take whatever number is in sensor value and divide it by 1023 and multiply it by 5. That will convert it into, and now again you have to tell the computer, when it does that, it has to put it into something. So you say, put your answer into another box called voltage. So what you should get out at that stage is 2.5 volts in that case, all right, or something close to it. I know it's not exactly 2.5. Okay, so the lines of the program to tell the Arduino how to deal with it is, you connect up the circuit the way I showed you already. You then say to the Arduino, you read what's in A0, read what you see. The Arduino will read it and put it into a box called sensor value. And then sensor value, you tell it, I want you to take the number that's in sensor value and I want you to divide it by 1023 and multiply it by 5. And I want you to put that into a box called voltage. And then you say to it, now I want you to print, that's not an exact command, I'll talk about the exact command in a minute. I want you to print voltage, or print to the screen, print screen voltage. Okay, so that's the idea. You're basically saying, read what's in A0, put it into a box called sensor value, take what's in sensor value, divide it by 1023 and multiply it by 5, put it into a box called voltage, and then print the voltage onto the screen. Okay, that means now our Arduino, and what you do then is you use the word loop, and you're telling, basically what you're saying to the Arduino is, keep doing this all the time. So basically, read A0, perform this calculation, print the voltage on the screen, read A0, perform the calculation, print it to the screen, read A0, perform the calculation, print it to the screen, and it will do that forever. It'll just keep doing it. So when you look at the screen of your computer, we have to tell it to put it on the screen of the computer. Our computer screen will just have a list of numbers of the voltage all the time. And if we left the thermistor at the same voltage, we would just see the same voltage all the time, constantly being printed onto the screen. If we then cover the thermistor with our hand and kind of warm it up, you should see that voltage go down in number, in value on the screen as we warm up the thermistor. Because remember what we said, when the temperature increases, the temperature of the thermistor increases, the voltage should decrease, and when the voltage decreases, the temperature increases. So that's the next step we do. Okay, but now our next problem, which I'll discuss in the next video, is how do we, that's only giving us a screen that's telling us voltage. How do we turn that voltage into a temperature reading? Okay, so I will talk to you next about how to do that.